Welcome back to your own channel, Data Science 24/7. So folks, in previous video, we have gone through what is data visualization, what are its importance, and types of charts. Now, in this video, I am going to elaborately discuss each and every chart. First of all, let's begin from comparison charts. In comparison charts, there are two types of chart that mainly comes, bar charts and line chart. Let's begin from bar chart. A bar graph shows comparisons among discrete categories. Discrete categories gender. Like gender has two categories, male, female, and others also sometimes. Apart from this, we have discrete categories as loan prediction, whether a loan should be approved or not. Then, third and usual example of discrete categories is marital status. It can be single, it can be married, it can be other. These are the discrete categories. So, one axis of the chart shows the specific categories being compared, and the other axis represents a measured value. For example, we can compare oil resources in different countries at any given point of time. So here, discrete categories will be different countries and measured value will be oil resources that can be in numbers count. Apart from this, the basic headline or bullet point of the bar chart is it is used for comparison, like compare of a measure along with different discrete categories. Discrete categories here is very important, and it is used for comparison. It is also very important. Next, bar chart can be broadly categorized into horizontal bar chart, vertical bar chart, and then there comes grouped bar chart. And in grouped bar chart, it comes double bar, multiple bar. So let's have a look of vertical bar. Why it is known as vertical bar? Because the rectangle bars is standing vertically, and here discrete categories is given on the x-axis. On the other hand, in horizontal bar, discrete categories, that is cosmetic products in this graph, is given on y-axis. That is why the rectangular bars are lying horizontally and hence known as horizontal bar. Now, grouped bar graph. In grouped bar graph, you have advantage of comparing various observations on the basis of more than one parameter, and based on the number of parameters used, grouped bar graphs can be further classified into two types. That is, if we have two parameters, will be known as double bar graph. If we have more than two parameters, will be known as multiple bar graph. This is an example of double bar graph. Here on x-axis we have discrete categories named as candidate. In y-axis we have count of votes. But on the x-axis, each category, each discrete categories has been judged on the basis of two parameters, and the parameters are year of election. Since we have two parameters only, that is why it is known as double bar graph. In this graph, we can have a look that on x-axis there are quarters Q1, Q2, Q3, Q4 for 2020 year, and in y-axis we have new revenue. But Each discrete categories has four parameters to be judged. That is, it has more than two parameters to be judged. That is why it is known as multiple bar graph. Uh, that is all in bar graph, I guess. Yeah. So it was a comparison chart. It has horizontal, vertical, double bar graph, multiple bar graph, and these are the most important points to remember in bar graph. That is all. Next important comparison chart is line chart. So a line chart, as the name itself is suggesting, there will be a line. So it is used to help understand trends, seasonality index of any series of data. So here we should underline series of data. For example, a time series data. Let us take for example a manufacturing company has their sales data based on time. That it can time can be weekly, monthly, yearly, quarterly, anything. And we have given their sales. And we are plotting a graph between them, like time and those data points. And what we'll be doing, we'll be connecting dots with a line. Then it is known as line chart. It has a vital role in detecting trend or pattern and seasonal effect also. Let us have an example. Here on the x-axis we have time, that is year, and on the y-axis we have a measured value. Here dots are connected with a line, hence named as line chart. Since here it is a single line, it is known as single line chart. There can be a more than a single line. For example, this. Here we have in x-axis a time series. That is, here we have monthly data. On y-axis we have total units. The third category, on the basis of what we are extracting information, is types of manufacturer, or that is why here are four manufacturers and hence four lines are there. So we can compare which manufacturer is doing good in which year, and that is why it is known as multiple line chart. So the key point to remember here is line chart is used for series data, and in data science generally time series data it is being used. There can be single line chart, multiple line chart, and yeah, it is used to detect trends, patterns, and whether a seasonal effect, right? So large effects also. So it is used to detect these things. Okay. So next type of chart that we have right now is composition chart. So basically two charts, pie chart and stacked bar graph comes under this. Pie chart is very simple, like we have gone through that in high school, right? So yeah, a pie chart is a circular statistical graphic which is divided into slices to illustrate numerical proportion. Numerical proportion. In a pie chart, the arc length of each slice is proportional to the quantity it represents. The last line, guys, here is very important. In a pie chart, the arc length of each slice is proportional to the quantity it represents. For example, here 8%, the arc length of the 8% will be or should be less than the arc length of the 25%. And the arc length of 25% should be proportional to the 25% only. And here, like in 34%, since it has the largest proportion in this pie chart, it should have largest arc length. and total comprises of 100%. I think that is all for the pie chart. Guys, in data science, pie chart can be used with the pie charts are used with another chart known as donut chart. For pie and donut chart, I'll make another video, separate video. I won't be uh, discussing it here. For pie and donut, I'll make another video. Okay, so after pie chart, we have stacked bar chart. So in stacked, as the name itself is suggesting, it is a column chart first of all, and data series are stacked one on top of the other in vertical columns, like this, on top of the other in vertical columns. Stacked column charts can show change over time because it's easy to compare total column length. Yeah, it is easy to compare total column length. For example, I'm explaining you the stacked bar chart with the help of this chart. For example, here we have on x-axis discrete categories. On y-axis we have sales, and the third category is products, types of products A, B, C, D. So for first strategy, with the help of first strategy, uh, we will be able to sell product A from 0 to around 80. So 80 products will be 80 product A will be able to be sold with the help of strategy 1. Then product B can be sold around 200 minus 80, that is 120. Product C have been sold around, let us consider it 340. 340 minus 200, 140. And the product D has been sold least, that is 410 minus 340, so it is 70. So this stat is showing the proportion of, or the composition of those discrete categories, proportion of the third category actually. So that is why stack bar chart is can be used for comparison also, like we are comparing strategy 1, 2, 3, 4, 5, which is working better, and for composition also, like here, like what composition of products A, B, C, D we have for first strategy, then second strategy, third strategy. Yeah, so we are left with two charts only, two types of charts only, that is relationship charts and distribution chart. These two types of charts are very much important for the data science skills, that I'll cover in the next video. Till then, stay tuned. Thank you.